Game theory is the branch of mathematics that studies strategic decision-making. It is used to model a wide range of situations in which two or more parties interact with each other, such as economics, politics, and biology. Game theory is a branch of mathematics and economics that studies strategic interactions between rational decision-makers, often referred to as players, who make choices that affect not only their outcomes but also the outcomes of others. It provides a framework for analyzing and understanding how individuals or organizations make decisions in competitive or cooperative situations. The basic elements of a game theory model are the players, the strategies, and the payoffs. The players are the decision makers, the strategies are the choices that they can make, and the payoffs are the outcomes that they receive for each combination of strategies. Game theory models can be used to analyze a wide variety of situations, including auctions. In an auction, the players are the bidders, the strategies are the bids that they can make, and the payoffs are the prices that they pay and the items that they win. Bargaining. In a bargaining situation, the players are the two parties involved in the negotiation, the strategies are the offers that they can make, and the payoffs are the agreements that they reach. Conflict. In a conflict situation, the players are the two or more parties involved in the conflict, the strategies are the actions that they can take, and the payoffs are the outcomes that they receive. Game theory models can be used to predict how players will behave in different situations, and to identify strategies that are likely to lead to good outcomes for the players. One of the most important concepts in game theory is the Nash equilibrium. A Nash equilibrium is a set of strategies such that no player can improve their payoff by changing their strategy unilaterally. In other words, a Nash equilibrium is a stable outcome in which all players are satisfied with their choices. Nash equilibria can be used to analyze a wide variety of situations, including the prisoner's dilemma. In the prisoner's dilemma, two prisoners are arrested and each is offered a choice: confess or remain silent. If both prisoners confess, they will each receive a prison sentence of 10 years. If both prisoners remain silent, they will each receive a prison sentence of 1 year. If one prisoner confesses and the other remains silent, the prisoner who confesses will go free and the prisoner who remains silent will receive a prison sentence of 20 years. The Nash equilibrium in the prisoner's dilemma is for both prisoners to confess. This is because each prisoner can reduce their own prison sentence by confessing, regardless of what the other prisoner does. The Cournot competition. In the Cournot competition, two firms produce the same good. Each firm chooses a quantity to produce, and the price of the good is determined by the total quantity produced. The Nash equilibrium in the Cournot competition is for both firms to produce less than the monopoly quantity. This is because each firm can increase its profits by producing less, regardless of what the other firm does. Game theory is a powerful tool for understanding and analyzing strategic decision-making. It can be used to model a wide range of situations, and to identify strategies that are likely to lead to good outcomes for the players. Here are some examples of how game theory is used in the real world. Economics. Game theory is used to study a wide range of economic phenomena, such as competition, pricing, and negotiation. Politics. Game theory is used to study political decision-making, such as voting behavior and international relations. Biology. Game theory is used to study animal behavior, such as foraging strategies and mating strategies. Game theory is a complex subject, but it can be a very rewarding one. By understanding the mathematics of game theory, you can gain a deeper understanding of how people make decisions and how to interact with others in a more strategic way. Here are some key concepts and mathematical tools used in game theory. Players. In a game, there are typically two or more players, each with their own set of possible actions or strategies. Players can be individuals, companies, nations, or any entity making decisions. Strategies. A strategy is a plan or course of action that a player chooses to pursue in the game. The set of all possible strategies for a player is called their strategy space. Payoffs. Payoffs represent the outcomes or benefits that each player receives based on the combination of strategies chosen by all players. Payoffs are often represented as numerical values, and they can be positive, representing gains, or negative, representing losses. Normal form games. In a normal form game, the strategies and payoffs of each player are summarized in a matrix. This matrix shows the payoffs for every possible combination of strategies chosen by the players. Extensive form games. In extensive form games, the game is represented as a tree-like structure that depicts the sequence of actions and decisions made by the players over time. It includes information about the order of play, player information sets, and possible outcomes. Dominant strategy. A dominant strategy is a strategy that is always the best choice for a player, regardless of the strategies chosen by other players. If a player has a dominant strategy, it simplifies the analysis of the game. Mixed strategies. In some games, players may use mixed strategies, where they choose their actions with certain probabilities. A mixed strategy represents a probability distribution over a player's pure strategies. Zero-sum games. A zero-sum game is a special type of game where one player's gain is exactly balanced by another player's loss. The sum of the payoffs for all players is zero. Cooperative game theory. Cooperative game theory deals with situations where players can form coalitions or groups to achieve certain objectives. It focuses on the distribution of the gains from cooperation among the players. Solution concepts. Game theory offers various solution concepts, including the Nash equilibrium, subgame perfect equilibrium, and others, depending on the specific assumptions and goals of the analysis. Mathematical tools such as linear algebra, probability theory, and optimization techniques are frequently used in game theory to analyze and solve games. Game theory has applications in economics, political science, biology, computer science, and various other fields where strategic decision-making is involved. It helps in understanding and predicting how rational agents will behave in complex and interactive situations.